So for section 7.2, we are looking at annuities and income streams. So the first example we're going to look at is this. You have $1,000, you are investing $1,000 a year for 5 years. And so you want to look at over time, how much money would you have after those 5 years? So one thing that you can do is to look at each $1,000 deposit separately. And so you would take like the first $1,000, so that's going to go gaining this continuously compounded thing for 5 years at 4%, right? And then you would do it again for that second $1,000 for the next 4 years, and the third $1,000 for 3 years, the fourth for 2 years, and the fifth for 1 year. And so each of these is a separate thing, but you would add them all up to figure out what's happening to the total over those 5 years. So when you add all of those up, you get 4650. So that's what an annuity is. It's a series of equal payments made at equal time intervals. And I wrote all this stuff down and I didn't show you the calculations, but this is tedious. So for longer periods of time, say this was over 20 years or something, this can be approximated with an integral. So it is an approximation, which is good. That an integral can help us do that. This is calculus is fun. So this is tedious even for short time periods. So we would like to be able to approximate this with that integral, and so that's really good that we can. So let me give you this formula. So the amount, this is going to be A, or future value of an annuity at the end of n time periods, months, years, whatever, is approximated by, so this is the future value, which is A. It's going to be the integral from 0 to n, the time periods, of P times E to the R times N minus T dt. And you can see here, we're taking the integral with respect to T. So the what would fall out here is that you would divide by negative R. If you worked that integral. So you're looking at this really. Where P is the number of dollars invested at each time period. So if you're making your mortgage payments, your car payments, the student loan payments, whatever, this value that you're doing over and over again, each time period is P, and then R is the interest rate. So let's do that for our example with the $1,000 invested every year for 5 years. So we're going to go, we're going to do P, which is $1,000, divided by, and we used 0.04. Oh, let me make a list of this stuff. So N is 5 years. That's an N. N is 5. P is 1,000. R, we use 0.04. And so we're going to do this and see how close we were. So the future value or the amount for this annuity is going to be 1,000 divided by negative 0.04 times E to the 0.04 times 5 minus T, evaluated from 0 to 5. So when you plug in, we're going to just like take this 1,000 over negative 0.04 out, and we'll plug in 5 first. So E to the 0.04 times 5 minus 5, which would be 0. Minus E to the 0.04 times 5, because 5 minus 0 is 5. And then that's that. This is negative 25,000 times 1, because that would be E to the 0 would be 1, minus, I have this as 1.2214. So this is 553507. And so this estimate of 553507 is pretty close to what we got here, 564650. So that's good. The integral helps us to estimate that value. Let's do another one here. We're going to invest $6,000 each year in an account for 8 years. The approximate balance at the end of the 8 years, if the account pays interest at 7% compounded continuously. So we have R is 0.07, N is 8, and P is 6,000. So we're going to do P over negative R, e to the R, N minus T from 0 to N. So this is going to be 6,000 divided by negative 0.07, e to the 0.07, 8 minus T, evaluate it from 0 to 8. So pull out that 6,000 divided by negative 0.07, and then we'll have e to the, once you plug in 8 here, this would be 8 minus 8, which is 0. So e to the 0, which is 1, minus e to the 0.07 times 8. And when you type that into a calculator, you get $64,343.36. So that's that. So suppose that money is, suppose that the money is not paid in equal amounts at regular time intervals, but flows almost continuously. So this would be something like ticket sales for an airline. So it's not in equal amounts, but it's like it flows almost continuously. So that's an income stream. So the amount of future value of an income stream at the end of T years is given by this integral. A is the integral from 0 to T, R of T, e to the R times big T minus little t dt. R of T is the rate of flow of revenue at time T. R is the annual interest rate, and it is compounded continuously. Okay, so let's use that formula and just sort of plug and chug here. So find the value of an income stream after 5 years. So T is 5. R of T is given there, and R is 0.07. So we have A is going to be the integral from 0 to 5 of R of T, so 3,600 times e to the 0.02 T times e to the 0.07, that's R, times big T, which is 5, minus little t, d little t. Okay, so you look at this and you think, oh, how do I evaluate this integral? So what we're going to do is to basically, when you have a, like you have a to the, what do we do? X to the A times X to the B. This is equal to X to the A plus B. That's what we're going to do here. So we have 3,600. I'll pull that out of the integral from 0 to 5 of e to the 0.02 T plus 0.07 times 5 minus T dt. So take the exponents and add them. And now we can simplify those exponents even further, actually. This would be 0.07 times 5 is 0.35. That's 0.35 minus 0.07 T. So we're looking at here, combining those like terms, we'd have e to the negative 0.05 T plus 0.35 dt. The 0.02 and negative 0.07 gives us the negative 0.05. Okay, and then doing this, you get 3,600 over negative 0.05 e to the negative 0.05 T plus 0.35. That's evaluated from 0 to 5. So it's the same kind of thing that you would use like a U substitution, basically. that U here is 0.05 T. So DU would be, well, negative, I guess, negative 0.05 DT. So 1 over 0.05 negative DU is DT. So put this in here, and that's where that comes from. All right, and then just plug this in, plug in 5 and plug in 0. You get 3,600 over negative 0.05. When you plug in 5 to this, you have e to the negative 0.25 plus 0.35 minus e to the 0.35. And then plug that into a calculator, and you get $600.56. Okay, so that is our first income stream. Let's do another one. Oh, this is going to be an annuity. This one down here. So we have $5,000 invested annually. So that's N is 5,000, or P is $5,000. R is 0.06, and N is 12. So our annuity amount here is going to be P over negative R, e to the R times N minus T, evaluated from 0 to N. So 5,000 over negative 0.06, e to the 0.06 times 12 minus T. This is evaluated from 0 to 12. So we have 5,000 times negative 0.06. And then this is going to be e to the 0, which is 1, minus e to the 0.606 times 12. This is $125,720.26. All right. Now we have here, the next one is an income stream. So we're going to use that integral. So remember, A here is going to be the integral from 0 to big T of R of T times e to the R times big T minus little t dt. So this has an income flow of $15,000. That's R of T. So it's actually a constant thing. So that's very good for the next 7 years. So that is big T. And this is R. So we have A is going to be 0 to 7, integral from 0 to 7 of 15,000 times e to the 0.05, 7 minus little t dt. So this is the integral from 0. I'm going to do 1,500 on the outside, or 15,000, sorry. 15,000 on the outside. The integral from 0 to 7 of e to the 0.35 minus 0.05 t dt. And then doing that same sort of u substitution thing, this is going to give me 15,000 divided by negative 0.05 e to the 0.35 minus 0.05 t. This is evaluated from 0 to 7. And then that gives me 15,000 negative 0.05. And this would be, when I plug in a 7, that would be e to the 0. So that's 1 minus e to the 0.35. This in a calculator. Oh, you know what, y'all? I messed this up. Sorry. Hold on. This is not 125,000. This is actually $87,869.43. My bad. This one is 125,720.26. Okay, so for these next couple, yeah, I'll just do them. That's fine. Okay, let's see. So we're doing an income stream here. This is R of T, then this is the rate of flow for the income stream for the next 8 years. That's big T. This is little r. So we're looking at A is going to be the integral from 0 to 8 of that income stream. So R of T times E to the R times big T minus little t dt. So pulling that 4,500 out. Now I'm going to write this as e to the 0.202t times e to the 0.42 minus 0.06t dt. That's an 848. Now I'm going to do that adding the exponents thing. So this is 4,500. That's an 8. 0 to 8. I'm going to add those exponents. So 0.02 minus 0.06 gives me negative 0.04 plus 0.48 dt. There's a t here. And then we're looking at 4,500 over negative 0.04. Once we actually take the integral, because with that u substitution, the negative 0.04 will divide by it. So e to the negative 0.04 t plus 0.48. This is evaluated from 0 to 8. Once you do that in your calculators, this gives you $49,788.40. All right, and we have another income stream here. This is R of T. This is big T. This is little r. So A is going to be the integral from 0 to big T of R, which is 1,500 e to the negative 0.03 t times e to the r 0.04 times big T minus little t dt. So 1,500. Big T is 8. No, 10. Okay. Times the integral from 0 to 10 of e to the negative 0.03 t times e to the 0.4 minus 0.04 t dt. And then we're going to add these exponents. So negative 0.03 and negative 0.04, that gives me e to the negative 0.07 t plus 0.4 dt. There's 1,500 out here still. Taking that integral gives us 1,500 divided by the derivative of the exponent. So negative 0.07 e to the negative 0.07 t plus 0.4 dt. No more dt. This is evaluated from 0 to 10. Once you do all of that and try it, you get $16,093.00, maybe. Something like that. So this is a lot of just like plug and chug for this stuff, get the right formula and then use it. I'll set this one up for you too. But you guys let me know if you have any trouble. Obviously the annuity stuff is easier because you don't have to compute an integral too. But this is the same sort of thing happens every time. So you can sort of see the pattern going on for the income stream. So this is big T, this is R of T, and the rate is 5.5%. So we're going to do the integral from 0 to 14 of 1,200 e to the negative 0.01 t times e to the 0.055 14 minus little t dt. Put that 1,200 on the outside, and we're going to try to add like terms for our exponents here. 0.55 times 0.055 times 14 is 0.77. Minus 0.055 t. And then add those exponents. This is a t. So e to the negative 0.065 t plus 0.77 dt. And then pull the derivative of that exponent out. So there's 0.065 e to the negative 0.065 t plus 0.77. Evaluate this from 0 to 14. When you do that, I got $23,822.92, maybe. You guys try those and let me know if you need more help. I know I did that kind of quickly, but it is a lot of plug and chug. Just pick the right formula and use it. But let me know if you need help with any of that.